Welcome to another lesson of doing neural network graphical interface using tkinter. In this tutorial we will look into training the neural network and the back-end logics of how it works. Now if we click load file buttons and training button, nothing will happen. First we need to look at how we can load the training feature data and training label data, prior to start the training process. Let's add a few variables to the view class. Flag load train feature variable will tell us if the training feature data is loaded. Flag load train label variable will tell us if the training label data has been loaded. We also create two variables to hold path information for file locations, so if user regenerates the network we can reload training data automatically. Next is to move to load train feature in view class. This method is triggered when pressing the load training feature button. Before we start load a file, first is to check if a network has been created. The status of this is updated when we creating the network in create nodes method. If no neural network has been created, then an error message box will display. We use messagebox.info from tkinter to do this. First parameter is telling what type of message box is this, and second one contains the content. In else statement, means we already get a network in this case. First is to clear the path variable. Then we use askOpenFileName class to pick file location from a dialog box. The first parameter is to define current folder path, second parameter is to define file types, to be separated by comma. Last parameter is to define name of the dialog box. In next line we put actual load of file action inside tkinter, because view class is only meant to handle user interface actions. The load train label method in view class has the similar routine. First is to check if training feature set has been loaded, if not show a message box to remind user. If it is a yes, clear the path variable and open a file picking dialog box to get file path. At the end, it calls load train label method in controller class and pass the file location. So that the load train label method in controller class can complete the actual process to load these data. Now let's move to create load train feature method in controller class. In load train feature method, first is to check if the path sent through from view has a length greater than 0. If so, means a path has been provided by user, we can save it in a class variable. And we show a message in status bar to inform the user. Because the loading process can take much longer depends on the amount of data. We create a list to temporarily hold the data. After that is the open file command. It takes two arguments, first one is file location. And second one is action. Here we use read only. In next line of code we load the file and break into lines. Let's look at what we are loading. The train feature data set is a group of X and Y coordinates, about 2100 of them. The neural network we wanted to train is for classification of a nonlinear function. It has three groups, yellow, red, and blue. Each result corresponding to 700 inputs. The load train feature method is to load them into a 2D list, so we can computer feed forward results. After we got lines from the file, then we close the file. For each lines we use .splitmoth from Python library to split them into two strings. Here we create an utility function called string2np, to turn them into NumPy float numbers. It returns a list of two float numbers instead of two strings. Now we move back to load train feature method in controller class. We append the two float numbers to a list, and save it to a class variable list train feature set. Before we do that, we need to clear it and add it to the top of the controller class. Now we assign list to train feature set variable. In the next line, we compare the length from the data set to the input node quantity to check if they are not consistent. If this is the case, what we do is to set the combo box in view class to match what's in the feature data set file. And just run create node method in view file to recreate the neural network. We can direct call view from controller or vice versa, because we have cross-referenced them in main.py. After that, we call setInputValue method in controller. What it does is to go through the first element of this list, get all values and assign them to corresponding input nodes. I create this so we have some graphic feedback on canvas when the data complete loading. Next line we set up flag for train feature load to be true. Also we update status bar content, so end user can know what has happened. This covers the situation when we do receive the file path from user. What happens if the user clicks on cancel on the file picking dialog box, and does not provide any file path for us to load? Let's look into what's in the else block. So under else block, first is to keep flag train feature load to be false. And clear the train feature set list variable. Clear any input value for input nodes in view class. The clear input value method in view class just set all input nodes value to 0.0. Let's move back to controller class. At the end we show status bar content as failed, so user knows what is happened. The else block just reset everything. This pretty much completes the load train feature data method in controller class. Let's now quickly review what we have done to load the training data. First, when we start with clicking the load training feature button, we pass the path received from file picking dialog box. If the path length equals to 0, which means no path has been picked, we just end the process and tell user the loading is failed. If the path length is bigger than 0, we then load the content of the file. We put file content by lines and then split line by comma get the data. Here we do another sanity checking, compare it with the neural network first row. If they are consistent then we proceed. If they are different, then we update input node setting on GUI, and recreate the neural network. Finally we replace the values in inputs nodes in view class by first set data, to demonstrate that the loading is successful. We have break the process into several small methods, which is easier to understand and debug. Let's test it. It load the file, correct the number of input nodes as expected, but it did not load the file properly. The reason seems is the lists are not consistent between view class and controller class. It must be the previous created the nodes has not be resetted properly. Let's have look into the clear method in view class. The idea is to reset everything for both view and controller class, so the network can be created based on new setout. We add reset for last x and last y variables. Clear v arrow list. Clear flat v node list and clear controller object. Now let's move into controller class to finish the clear method here. We clean the number of input, and number of output variables. Clear list of number of hidden layer. Clear list of weights. Clear list of flat weights. Clear list of bias. Clear list of flat bias. So they will be ready to receive new data from view class. Time to test it again. Now it works as intended. It loaded file, updated the number of input nodes to match train feature data file, and show the first row of data onto canvas, and notice user the loading has been completed in the status bar. Before we jump into load label file codes, let's look at the data files. On left is the feature file, the coordinates of the dots. And on the right is the label file, contains one in 3 different positions. What they present are 3 group of dots to be classified or trained. There are 2100 set of coordinates and labels. Labels are divided into 3 sets, each contains 700 result. They correspond to each other in these 2 files. We use the left side coordinates data set to do forward feeding. And use right side label set to calculate the cost function, or we can call it error index, and do back propagation. The load label file methods is similar to load feature file methods. We have already created load train label method in view class. Now we just need to complete load train label method in controller class. I won't repeat here, as the logic is the same as that of load train feature method. After we complete the load train label method in controller class, we need to clean up some residue code. And add 2 variables in the initial method. First the flag load label. Second is a list hold the label set data called train label set. Now we can test it. We create a network with 3 input nodes, and 4 output nodes, so we can test if they will be corrected based on the data in files. It works fine, with nodes in both ends got corrected based on file data. Also the status bar is working as well by showing user what has happened. Thank you for watching. If you like this video, please thumb up. Please subscribe for upcoming interesting videos. If you have any questions, please feel free to post as comments.